lesson 5, we are going to explore what happens if our terminal ray, so remember there's 2 rays we talked about. One ray is right here. We'll mark this as our initial ray. Right there. And the question is, what happens if we were to take that initial ray, and so we'll highlight that in red. And so here's the idea. We take this and we rotate this. That's going to rotate the way that we want it to. What if we were to go all the way around the circle? It's not going to do that today. And keep going and going until it gets to what we want. I think we can do that by doing this. Extend this to here. What if I went all the way around to the top? That's 90. And then over here, we said yesterday was 180. Down here at the bottom is 270. Here is 360. What happens if we wanted to keep going, right? What if we went to 360 and kept going? Would it go 361, 362, 363, and so on? And that's what we're talking about here. And this is the sign of 405. And so if I kept going and going and going, 405 would be right here. Now, how do I know that? Let's talk about that. If I took 405, 405 is obviously larger than 360. So if I took my 405 and I minus 1 complete rotation around the circle, so 405 minus 360, I'm going to get 45 degrees. So thusly, we know that 405 is equal to 1 360-degree rotation, meaning 1 time around the circle completely, plus another 45 degrees. That's going to take us there. Now, why is that significant? Is we know where 45 degrees is at. It's right here. And so we took our rotation, and we started here, and we rotated all the way around the circle just to show this rotation. And then let's draw that again. Let's see. And then we went all the way around the circle, and we went 45 degrees more. Now, outside of that, right, here's what we know. We can then say that this line is going to go straight down like we did yesterday's lesson, go straight down. And we note that this degree right here is a 45-degree angle, just between here and the x-axis. That makes this 90 degrees, and that makes this also 45 degrees. So while we are doing the sine of 405, that is equivalent to the sine of 45. They're going to be exactly the same. So if that's the case, then on all of our unit circles, we know that this is 1 because our unit circles are x squared plus y squared equals 1. And since these are 45, 45, 90s, we know that this is going to be the square roots of 2 over 2. And this is going to be the square roots of 2 over 2 as well. What else can we note? That we were in the first quadrant. So everything in the first quadrant is positive, positive. And so we henceforth know that this is going to be the square root of 2 over 2. And then we know that the cosine of 405 is going to also equal the square roots of 2 over 2. Remember what we're finding, just to make sure we're all clear, is that as we rotate this around, we ended up crossing the circle at a given point. We call that point P, which is x, comma, y. Our x becomes known as the cosine, and our y becomes known as the sine. And so that gives us a positioning along the edge of the circle based on what we're looking at. So the reason why this is important is this no longer limits us to going around the circle one time. We can rotate this around the circle as many times as we need to, and we know that we're going to land somewhere along that circle, and then we subtract 360 until we get to something that is below 360 that we can identify and relate it to in terms of a reference angle. So if we look at exercise number 2, we have 840. So just to remind ourselves, we have our initial ray right here. And if we wanted to go ahead and do this first, we could say 840. We could minus 360. So 840 minus 360, and that gives us 480. Now, because that is still over 360, we could subtract that one more time. So minus 360 again, and we get 120 degrees. So what do we know? That tells us this information, that 840 is a 360 plus 360. That means we went completely around the circle 2 times, and then we added 120 degrees. So what does that mean for our terminal ray? Well, that means I took my ray and I went all the way around the circle 1 time, and then I went all the way around the circle 1 more time, and I went another 120 degrees. So I go up, 30, and then 45, 60, 90. 120 is 30 degrees more than 90. So I go 30 degrees over past 90, and this ends up being my given ray, which means I'm going to take and draw a line straight down. And so here's what we know, that this within one context would be like 120 degrees. Now, make no mistake, we did go around the circle, right? 1 time. Can't seem to draw that real good today. We went around a 2nd time, and then we opened it up to 120 degrees. So with that being the case, we have to note reference angles. If this is 180 right here, the difference between 180 and 120 is 60 degrees. So that makes this angle 30, and that makes that 90. So now we're able to identify the cosine of 840 is going to be equal, and then we'll have the sine of 180, 840, right? And that's going to be equal. And what we're doing is we're working with this information here. So we know that this is a 1, and this right here opposite the 30 is the negative 1/2. And then over here is the square roots of 3 over 2. So remember, we're trying to figure out point P. Point P is here. Point P is x, comma, y. Everything in this quadrant is negative and then positive, hence why we have the negative 1/2 and the square roots of 3 over 2. And so we can say that the cosine of 840, based on this triangle here, is going to be negative 1/2. And then the sine is going to be the square roots of 3 over 2. Right, so if we looked at number 3, they got 1,680. So obviously, in this case, we're going to be subtracting 360 several times. If you don't want to keep subtracting 360 over and over again, what you can do is figure out how many times does 360 divide perfectly into it. And so I'll just make a note here on the side that 1680 divided by 360 is 4.6 repeating. So what we're interested in is we're interested in this 4. So 360 times 4 is 1440. So 1440. So 1680 minus 1440, and we're going to get 240. Now, what does that mean? Right? Let's make sure we understand this idea. So we have our initial ray, which is right here. And we take our terminal ray and we rotate around 1, 2, 3, 4, and we're going to go to 240. So this is 90, 180, 270. 240 is 30 degrees before 270. And so we end up with this piece here. Now, what does that mean? That means I'm going to take and I'm going to draw a line from where it intersects the circle straight to the x-axis, just as we did yesterday's lesson. And so we make some notes that this is 180 degrees. This is 240 degrees. The difference between 180 and 240 is 60. That makes this side right here, this angle, my 30. So since my radius is always 1, this will be negative 1/2, and this will be negative square roots of 3 over 2. Remember, if you're having a hard time remembering from yesterday where the 1/2 and the 3 square roots of 3 over 2 is, please go back and view yesterday's video again to get a recap of how that worked. And so now that we know that, we can now identify the cosine of 1680 as negative 1/2, and we can state the sine of 1680 as the negative square roots of 3 over 2. Again, I can't say enough now. You need to start to understand that we're finding this point right here, x comma y. The x value is known as the cosine. The y value is known as the sine. And so you should make those synonymous. This is going in the x direction. This is going in the y direction. That's why this is negative and negative, because everything in this quadrant is negative, negative for that perspective. All right, so let's take a look at number 4. Number 4 says 2,115. So we put our initial ray, and what we're going to do is we're going to do 215. Let's see, 2,115. We're going to divide that by 360. So 2,115 divided by 360. That's going to be 5.875. So what we're going to do is we're going to do 2,115, and we're going to minus that from 5 times 360, because we're interested in this 5. So 5 times 360 is 1,800. So we subtract those two, and we get 315 degrees. See, 315 degrees is below 360. So what does that mean? That means ultimately, and I'm not going to show all the rotations, we took this and we rotated it around 5 times. Now, after 5 rotations, we're looking for 315, 90, 180, 270, right? 315 would be right in the middle. And so now that I have that, I can draw this line straight up, and that signifies to me that I have a 45, 45, 90 triangle. We're in the fourth quadrant, so everything is positive, negative. So that means this is going to be a positive square root of 2 over 2, and this would be a negative square root of 2 over 2. And so when I want to know the cosine of 2,115, we say that would be the square root of 2 over 2. And the sine of 2,115 would be the negative square root of 2 over 2, because the y value is negative in that particular quadrant. So this can be done over and over and over again. It does not matter how big of a number you go. Let's say we go to a really large number like this one, 720,030 degrees. We're still going to start by dividing by 360. So 720,030 divided by 360. That's going to be 2,000.08. So what we're going to do is we're going to multiply 360 by 2,000. So 720,030. We're going to minus, so 360 times 2,000 is going to be 720,000, and so we just get 30 degrees. So that means we rotated our terminal ray around this circle 2,000 times. Now, obviously, I'm not going to show that because that's a lot of times to rotate that. And then after all those rotations are done, we ended up at 30 degrees, just 30 degrees above the x-axis. So we take our and we draw our line straight down. So this will be 30, 60, and 90. That means this is going to be 1/2, and this is going to be the square roots of 3 over 2. So that means I know that the cosine of 720,030 is simply going to be the square roots of 3 over 2, and the sine of 720,030 is going to be 1/2. Now, on the other thought of this, if we go to exercise number 6, what if we had negative 30 degrees? Now, all that means, right, we're not doing anything really that different beyond this fact. So if our initial ray is here, if positive 30 degrees is right here, meaning I'm rotating counterclockwise every time. If I want to go negative 30 degrees, that means I'm going to go 30 degrees clockwise. So I'm going to go in this direction. Now, it doesn't change very much other than the fact that I'm going clockwise. So I still draw my line right here. I still know that this is a 30-degree angle, and that this is a 60, and this is a 90. And so this is still going to be negative 1/2, and this is still going to be the square roots of 3 over 2. It's just all we did is we did 30 degrees clockwise. We went down instead of to up and left. And so if I want to know the cosine of negative 30 degrees, then that's going to simply be the square roots of 3 over 2. And if I want to know the sine of negative 30 degrees, then that's going to be negative 1/2. And this continues to play out. If we did negative 135, right? So if we looked at that, my initial ray would be right here. My terminal ray would be here. And since it's negative, I'll go clockwise. So this is like negative 90. This is negative 180. So it means negative 135 would be nestled right in the middle. Now, after you have that rotation, we go back to doing exactly what we did before. We note that this is a 45, 45, 90 triangle. That means this is going to be the square root of 2 over 2, and this will be the negative square root of 2 over 2. So if I want to know the cosine of negative 135, then I know that is, actually these are both negative, negative square root of 2 over 2, and this sine of negative 135 is going to also be negative square root of 2 over 2. And again, just to emphasize that, that's because everything in this quadrant is negative, negative, and we were finding this point right here, point P, which is an x comma y. This x again is known as cosine. This y here is known as sine. So then they're going to ask us and remind us that this still works even though we're going clockwise. We can still figure out how many times we're going to rotate. So if I did negative 1, 3, 2, 0, and I divide that by 360, right? Whether it's negative or positive is irrelevant. So 1, 3, 2, 0 divided by 360. And so that is equal to 3.6 repeating. And so we want to know, right, if I did 1, 3, 2, 0 minus 360 times 3, that's 1080. And so we're going to get 240. Now remember, that's going to mean we're going to do the negative 240 because we're going clockwise. So we have this, we have our terminal ray. We go around once, twice, 3 times, and then 240. This is 180. This is 270, so we come back this way. So this would be negative 240. So we would draw our line straight down. We can then note that if this is 240 and this is 180, then this difference here is 60 degrees. This would be 30. This would be our 90. And so that means this would be negative 1/2. And this would be the square roots of 3 over 2. So then we could say that the cosine of negative 1320 is negative 1/2. And the sine of negative 1320 is going to be the square roots of 3 over 2. So it just gets repetitive after that. I think this has been 1, 2, 3, 4. This has been 8 that I have modeled for you. That is probably enough at this point. And you should be set to be able to go into the problem set at this point. If you have any questions, be sure to let me know.